Welcome, viewers, to another part of organic chemistry, brought to you by K.Creative's Academy. I am your tutor, Kondwani Kaira, Mr. Kaira. Yes, and we will look at the second part of organic chemistry. We are still looking at the 2023 internal paper, science paper 2. So in the part one of organic chemistry, we looked at the question which was in section B on alkanes, but and we also briefly talked about the other homologous series. So this question came in section C. It was question 3 of section C. So ethane and ethene are both organic compounds. Okay, ethane, ethane and ethene are both organic compounds. Compare how they react, if at all. Okay, if at all. Roman numeral 1, oxygen gas. Okay, compare how they react. Okay, so the question is asking you to compare how ethene reacts with oxygen gas, and how from compare with uh, the reaction of ethene with oxygen gas, and the reaction of ethene. This is ethene with oxygen gas. Okay, then Roman numeral 2, we are still comparing the two, how they react with how each of them react with hydrogen gas. Okay, then Roman numeral 3 says write a chemical equation for any of the reactions in 1 or 2. Roman numeral 1 or Roman numeral 2. Then B, draw the displayed structural formula of ethane and ethene. Okay, then E, describe a chemical test that can be carried out to distinguish ethane from ethene. Okay, so this is how they both react. So remember, just a recap. Ethane is coming from the homologous group of what of the alkanes. Okay, how am I able to tell? I'm able to tell from the suffix which it is ending with. Okay, which is it is ending with ane. Okay, as you can see in ethane, it's ending with the suffix ane. Okay, then ethene is coming from the homologous group of what of alkenes. Okay, alkenes. Why? Because of the suffix ene. Okay, the suffix ene. Okay, okay, and the this is the answer for Roman numeral 1. Okay, so both alkanes and alkenes react with oxygen. Okay, a reaction called complete combustion, producing carbon dioxide and water. Okay, so the alkanes, they as well react with oxygen, despite them being less reactive, as I mentioned in the previous video. But I emphasize that with the exception of oxygen, alkanes react with oxygen to produce carbon dioxide and water. Okay, they undergo a complete combustion. Okay, then uh, Roman numeral 2. So we are now comparing them how they react with hydrogen. So alkanes do not react with hydrogen. My goodness, that spelling. So it was supposed to be, it is supposed to be hydrogen. There, the spelling is supposed to be like this, hydrogen. Okay, hydrogen. Okay, so uh, under normal conditions, alkanes. Remember, we said that alkanes are less reactive. Okay, so when it comes to reacting with hydrogen under normal conditions, the alkanes can't react with hydrogen because they are saturated hydrocarbons. that spelling of hydrocarbons as well, it's supposed to be hydrocarbons, hydrocarbon, like that. Pardon my technical errors. Yeah, so with hydrocarbons, unless when extreme temperature and pressure is applied, okay, unless the alkanes are put under high temperatures and pressure, that's when they will react with other substances like hydrogen. Okay, alkanes on the other hand uh, react with hydrogen, okay, under normal conditions in the presence of a catalyst called nickel. Okay, so this is why this is let me explain to you the reason why alkenes will react with it with hydrogen, because remember the chemical structure, the general molecular formula for the alkenes is 2N, okay, of which ethane comes in the second group of the compounds, meaning the carbon atoms it has two, and this is what we'll use to represent for N. So meaning that the structure will be C2H2 multiplied by 2. That will be that will give us 4. Okay, 4. Okay, so meaning that the structure, okay, the structure of methane will be carbon to carbon, then with 4 hydrogens. Okay, 4 hydrogens. Okay, so but this compound is unstable, so in order for it to be stable, instead of adding more hydrogens this side, the as in ethane, ethene has a double bond in between the carbons. Okay, and these double bonds, they have the ability to open up. Okay, when they open up, the bonds become like this. Okay, so as you can see on the ends of these bonds, these these bonds are highly have a high affinity, meaning that they are ready to accommodate other elements. Okay, like hydrogen. Okay, hydrogen can bond on this side, also another hydrogen can bond on that side, of which the if ethane reacts with if ethane reacts with hydrogen, the structure that will be formed will be ethane. Okay, as you can see, that's the structure of ethane. Okay, so yeah, and this reaction will take place in the presence of a nickel catalyst. Okay, okay, then question 3. Write a chemical equation for any of the reactions in Roman numeral 1 and Roman numeral 2. So I chose to write the chemical equations for Roman numeral 1. Okay, where ethane, okay, that's ethane, where ethane when reacted with oxygen, oxygen gas, it will produce carbon dioxide and water. Okay, that's the balanced chemical equation. And ethene, when reacted with oxygen, it also produces carbon dioxide and water. Okay, yeah, under sufficient supply of oxygen. These are the reactions of complete combustion. Okay, then question B. Uh, Draw the displayed structural formula of ethane. Draw the displayed structural formula of ethane. Okay, so the displayed structural formula. So I've already shown the general molecular formula that we will be using when drawing these structures. Sorry, I have noticed another error here. So in the question, what we're having in the question is methane. Okay, what we're having in the question is ethane. Ethane and ethene, not methane, not methane. So yeah, as we are taking notes, cancel correct these mistakes. Yeah, so it's supposed to be ethane, ethane, and ethene. Okay, and ethene, like that. Okay, so if we were to use the general molecular formula, uh, for methane, it comes second in the list of the compounds, meaning it has how many carbon? Two carbon atoms, and this is what we'll use on N. Okay, so meaning that the structure, if we put two there, then on H we also put two there, multiplied by two, then plus 2. So this will give us a structure of C2H6. Okay, that will be the structure of methane. Okay, so the structure will be C2H6, and since we are drawing, this is how the structure will be. It's having two carbons, so we join the two carbons. Remember, in alkanes, there's only a single bond between the atoms. Okay, then the hydrogen atoms. Okay, so the hydrogen atoms will be bound there, like that. Also there, like that. Okay, let's look at how a thing will look like. So a thing also in so this one will have, how many carbons does it have? Two, and that's what we'll use it to represent on N. Okay, so we will say C2H2 multiplied by 2. Okay, of which this will give us C2H4. And this is how the structure will look like. Okay, so have two carbon there with four hydrogens. One, two, three, four. So since there are only four hydrogens, this will have a double bond like that. And then the last question, which was supposed to be question C. The examiner made a mistake on this one, so this was supposed to be question C. Describe a chemical test that can be carried out to distinguish ethane from ethene. Okay, so here is the answer. So by using a bromine test, put a small amount of gas, so that gas can either be methane or methane, and add a few drops of bromine liquid. If the bromine liquid changes to colorless, then the gas was methane. Okay, methane. Because of the double bonds, unsaturated hydrocarbons, the double bonds will open up and accommodate bromine. Okay, because it is an halogen. And if the bromine liquid remains reddish, brownish, then the gas was methane. I mean, the gas is methane. Okay, guys, that marks the end of part 2. Thank you for tuning in. Shalom, shalom. Don't forget to like, share, and subscribe. If you enjoyed the video, please click the like and subscribe button and tune in for more.